Okay. Good morning, all. Welcome to the another lecture of 80 instructions of 8085, and I hope you are enjoying these classes. And last time we have done with some of the instructions of say data transfer group and arithmetic groups. So some of the instructions which are left, we'll try to complete those instructions in the coming classes. And today, in this lecture, what we are compiled for you are 8085 logical instructions and branching instructions. So logical instructions like AND, OR, XOR, and such sort of instructions are there. So we will go one by one. Let us start with those instructions. Yeah, hold it for a second. Yes. So logical and branching instructions. So let's start with some of the logical instructions. What are logical instructions actually? So logic, we have worked on logical gates, logic gates, and or XOR, and similar gates. So we will work on such type of instructions which are really going to perform those operations on the 8-bit data now. We will not work on 2-bit data. In AND gate, we are having 2 inputs and 1 output. That I'm going to show you. So we are having these sorts of logical operations like AND, OR, XOR, rotate, compare, complement. As you will come to, as we'll proceed, you will come to know what are the rotate, compare, and complement instructions. Those are instructions are really useful while performing the programs, right? So we are going to those. We are going to use those instructions in that manner. Right. So next is the logical instructions, which are very much related to the program status. What that those are flags, right? So in data transfer group, I have told you that the flags are not being affected, right? Flag means sign, carry, auxiliary carry, parity, and zero flag. Yes. So we are having these flags, and what are their meanings? What are their implications? So that is what we have expected to study over here. 0 means the flags are reset, and 1 means the flags are set. So remember that whenever I say the flags are set, implies that the flag is having 1 as the output, right? Where whenever I will say reset, means the flags are reset. That means that particular flag is having a 0, right? So these are the flag status, program status word, and their bit positions are written over there. Here, sign is written at bit 7th place, 0 is written at bit 6th place, and auxiliary carry at 4th place, parity at bit 2, and carry at bit 0. So this carry flag is very important for us, and we are going to use this carry flag many a time when we'll do the branching instructions. Like so, this carry flag is is very important. Now, what is AND gate? Let me brush up, refresh some of the portions that we have studied. I will just take one of the gates. So we have studied this gate, that is AND gate. What was it like? So an AND gate accepts 2 input signals, right? So we'll be working on 8 bits. So I will try to give you an example also. So what was it? If the first input and second input values for an AND gate are both are high, then only the output is high, otherwise it is low. This was the definition of AND gate, if you are remembering it. So this was some of the that was the logical symbol, Boolean expression, and this was the truth table. Now if you are able to see here, we are having 2 inputs, A and B, and X as the output, right? 0 0 gives the 0 0, 1 gives the 0, 1 0 gives the 0, and 1 1 gives the 1. So this is actually called as the ANDing operation. Now coming to the actual our 8-bit, how 8-bit ANDing is going to perform, and similarly how AND, XOR, and ORing is operations are going to perform, that we are able to see. So I will give just this example. So let us try one problem or one program like. So this program actually is meant to do 8-bit ANDing operation and numbers, right? So I expect from you that as you have done the add program, add 8-bit to 8-bit numbers and store the result in register C. So the similar program is written over there. Let us try to analyze this program. So while analyzing, what we'll do, what is the main job of this program? This program is prepared to ANDing of two 8-bit numbers, and that is to be done in this program, right? Now how you are going to do that program? So program logic is add two numbers, store the result in register C. Let us try this example. So I have tried to make this example. So I have used this hexadecimal number 9B, right? If you are able to see 9BH is over there, and in binary it is written as 1001 and 1011. So this is to be stored in register A, which is shown in the pink color, right? Then let us start with the second number. What is the second number? Let us try this 35H. So 3 is 0011 and 5 is 0101, right? And that is to be stored in register D. So in hexadecimal, it is shown as 9BH and 35H. Now this is to be stored initially. These are the data, right? Now what happens when we AND this? So let me show you that. When we AND this, I've just written here sum, but it should be like dot, right? So it is dot. Imagine this as dot. So this is not summation. This is for OR. Summation is for OR, right? So we are having here dot product. So yes. So what would be the result? So when I say that we have to AND two 8-bit numbers, what we will try to do is, this is one 8-bit number and this is the another 8-bit number, and we will try to AND these two bits, right? The simultaneous bits are to be ANDed. So I will start from the least significant bit, which is over here. Both are 1 1, implies that the AND the operation will give us 1, right? As you have seen in the AND truth table diagram, right? So the 1 1 is 1, 1 0 will give us 0, 0 1 will give us 1. Sorry, this must be again 0. Yes. So I will just change it. This is again a 0, and right. So this is a 0. Then 1 0 will give us again 0. So this is again a 0. I hope it has been just shifted, right? So that is why it is coming likewise, right? So 1 0 is again 0, and yes. So 1 0 is 0, 1 1 is 1. This is again 0, 0 1, 0 0, and this is also a 0, right? So the output that is expected to come over here is I hope 1 1, right? So this must be 1 1 in hexadecimal. So just we will again push it and we will try to solve this. So this was the example, right? So now this is 9BH and this is 35H, and while ANDing, this is the expected result. So if you are able to see, 1 1 gives us 1, 1 0 gives us 0, 0 1 gives us 0, 1 0 again gives us 0, 1 1 will give you 1, 0 1 will give you 0, 0 0 will give you 0, 1 0 will give you 0. And the hexadecimal code of this is 1 and 1. So 11H, that is to be stored in register C, right? So this is a simple program that you might perform. Just go through that addition program and put this ANDing operation over there, and you will get this result. Even if you are not able to get this, we'll try to solve it, right? So let us try. So this is one of the example what I really means when I say that we have to do the AND operation into 8-bit numbers, right? So I hope you have understood. If you have any queries, put it on the chat box. So let us continue. So what are the other instructions that we are having? So we are having these types of logical instructions, AND, OR, and XOR. These three operations are there in 8085. So AND operation, OR operation, and XOR operations. And this is again considered as one of the data should be in the accumulator by default, right? And the result is also stored in the accumulator itself. So this is the example. These are not the instructions, these are just the examples. Rotate. Each bit in the accumulator can be shifted either left or right depending on the instruction in the next position. So this is the rotate. Then we are having, I'm not showing you the instructions as such right now. So I'm just telling you what are the logical instructions, logical instructions and what they contain. So compare what type of comparison it can do. That is any 8-bit data or contents of register or memory we can compare. Location can be compared for equality greater than or less than with the contents of the accumulator. Again, we are going to compare with the data which is in the accumulator, and the results are not being altered. Accumulator के contents या और किसी register के contents alter नहीं होते, only flags are being affected. So using those flags condition, we can give other instructions, right? So these are compare. Then we are having complement. Yes, complement means just to convert 1 into 0 and zeros into 1. So we have a complement of A. We can have a complement of registers also. So complement means we are just converting zeros into ones and ones into zeros of binary, right? So we'll try those examples also sometimes. So these are the complements. So these all comes under the logical instruction. Let's start with the instructions now. So the first instruction, that is compare R or compare M. Now where we are going to compare with this? The content of register R is to be compared with the contents of the accumulator, right? So one of the data by default should be in the accumulator. This is the must of any of the instructions. So what we are supposed to do with the compare register or memory with accumulator. Now the contents of operand, that is the register or memory, are compared with the contents of the accumulator. Now both the data are remain unchanged. They are not changed, right? So they are not altered. So they are preserved. So both the contents are preserved. What is going to change? The flags, sign, carry, auxiliary carry, and parity and zero. These flags are being effective. Now actually what the compare instruction does is, this instruction subtracts the contents of register with the contents of the accumulator, right? Remember this, what I am saying. This compare instruction subtracts the contents of the register or memory with the contents of the accumulator without changing the contents of accumulator and register both. They are not going to be changed. But this is the basic of that. It just subtracts, and what are affected? The flags are being affected, and those flags tell us whether the number which is being compared is equal or greater or less than the data of the accumulator, right? So this is what we are going to use this. So this is one of the instructions. Remember this. This is a compare instruction, right? So all the flags are being affected, right? Then we are having the second instruction as compare. Yes, this is the same instruction that I'm showing you. So if we are having accumulator, the contents of accumulator is less than the content of register or memory, then carry flag is set. Set means it is 1, and reset means it is 0. So if the content of accumulator is less than register or memory, carry flag is set. If the content of accumulator and register are equal, then 0 flag is set. If accumulator is greater than, the content of accumulator is greater than the content of register or memory, then carry and 0 flags are reset. Remember this. So these conditions we have to use it for the further processing. So compare B, compare M. Now we have one program in the list that is provided to you, that in which we are giving you the array of some of the data, where we have to check how many times EB number appears in that. So we have given say 256 numbers, and we have to check all the 256 numbers, and we have to say write a program to give you the exact number of EB in that 256 numbers, right? So how we are going to do that? This compare instruction that we are going to use. So remember this. So this is the compare instruction. Then the next logical instruction is compare immediate with the accumulator, means immediate data. So now here data is to be specified in the instruction itself. So it is having a 2 byte instruction. So one is the opcode and the other one is the data. So this is the instruction CPI, compare immediate with accumulator. So it is going to compare the data which is specified in the instruction itself, right? So this is another instruction of compare. Then again, the same procedure, all the flags are being affected and the contents remains the same. They are unchanged. So this is another instruction. Then logical instruction, what it does, the same as we have seen earlier in the compare register or compare memory, the same sort of flags are being affected. And this is one of the example given over there, CPI 89H. H stands for hexadecimal. So this 89 is to be compared with the content of the accumulator, and accordingly, it's the carry flag, zero flag, and are being set or reset, right? So this is that compare instruction. The next instruction is AND. So A and register or content, register or memory with the accumulator. A, right? So this is these are the mnemonics. Opcodes are different, right? So A is and the ANDing the accumulator with register or the memory, as I have shown you in the program, right? The result is placed in the accumulator itself. If the operand is in memory location, its address is specified by the contents of the register pair HL, as we have already studied. Sign, zero, parity are modified to reflect the result of the operation. Carry is reset and auxiliary carry is set. Remember this. So we have these instructions A and A, B means you can use any register. So we are here using B register. That's why I have written A and A, B and A and A, M, right? And the memory, which the location of which is specified in the HL pair. Now, there is one condition always arises, that I have to make the accumulator as 0, right? So if I need to make that accumulator as 0, I can use this instruction and XOR is the instruction that we are going to use. Yes. So I will try that. I will let you know that it will give you the result of the accumulator as 0, right? So this is the AND operation. Then the next is ANI, I hope, yes, and immediate data with the accumulator. Similarly, as we have used CPI, compare immediate, similarly ADI, similarly ANI, right? Logical and immediate with the accumulator, which the data is specified in the 8-bit register, in the instruction itself, right? So these are all there. Carry flag is reset and auxiliary carry is set. Example is ANI 86H. So 86H is the data which is to be ANDed with the contents of the accumulator. Now the next instruction which is there is OR operation. So ORA A. So OR the contents of accumulator with the register or memory, right? So ORA A, right? So examples are given over here: ORA A, B, ORA M. If we are using it for memory, then the location is to be specified in the HL pair, right? The contents of the accumulator are logically ORed with the contents of the register or memory. So sometimes you will require these instructions also. So these are all instructions, logical instructions. And similarly, we are having ORI immediate, the 8-bit data, right? Again, sign, zero, parity are modified and reflected in the results. Carry and auxiliary carry, the results are stored in the accumulator itself. So these are some logical. Then we have start. Yes, the next is the XOR. So XRA R, XRA M. So XOR the contents of accumulator with the register or with the contents of the memory. So these are the another instruction. Now here we are going to perform the XOR operation, right? Okay. Now what is XOR? So XOR is whenever there are different inputs, the output is 1. Whenever there are same inputs, the output is 0. So what I mean to tell you here is, whenever we have to make the contents of the accumulator as 0, whenever we have to make the contents of accumulator as 0, what we will use? We will use this instruction exarray A. Now what will happen? The contents of the accumulator are being XORed with the same contents of the accumulator, exarray A, right? So by doing that, the same contents are being XORed, in which if there are same inputs, then the output is supposed to be 0, right? So the contents of accumulator will automatically become 0. So this instruction we can use here. Again, all the flags are being affected. Carry and auxiliary carry flags are being reset. Exarray B, exarray M are some of the instructions. So this is over there. Then we are having exar I, immediate sort of instruction, same instruction. Just the immediate data is to be specified in the instruction itself. So 8-bit data is to be given over there. Then we are having yes, RAL, rotate accumulator left through carry. Remember this. I'm going to specify this example now. Whatever the data is there in the accumulator, say that is 8-bit data. Now we have to rotate this data to the left by 1, right? We are moving the data in the accumulator. Now, what it means? I just imagine. So if I say that I have this AA in the accumulator, and these are the flags, right? So here we are having 8-bit flags. Here we are having 8-bit register A, and in that register A, what we are having AA. So AA is written as 1010 and 1010, right? When I use this instruction, RAL, rotate accumulator left, what happens is the data is being rotated likewise, right? So, and through carry. So if I imagine that the 1 is there in this carry, if you are able to see my screen, if 1 is there in my carry, so that carry is being rotated from here to the first LSB, right? So initially it was 10101010. Now this data, this 1 is going to be shifted over here. This 0 is going to be shifted over here, and likewise. So it will go on shifting the data in the left side. So RAR, rotate accumulator through carry, and this 0 or this 1 is going to shift in the carry flag. So this is how it happens, right? So after the first RLC, RAL, the carry flag, the data is being shifted to the left, and this data is of the accumulator. Therefore, it is become R, rotate accumulator left, right? Through carry means the carry is also being rotated along with this, right? So this is the instruction. I hope you have understood this instruction. So the next instruction is RAR. Similar is the instruction. RAR means now we are moving the contents of accumulator to the right. So there is one more program. Count the number of ones in the accumulator or in a 16-bit number. तो ये एक बहुत बड़ा प्रोग्राम है. इसको हम लोग accumulator में डाल देंगे और इसको रोटेट करके कैरी गिनते जाएंगे कितने बार 1 आए. वो गिनकर हम लोग बताएंगे एग्जैक्ट नंबर क्या है. So this is one of the program which will come in the which is there in the listed in the programs list. तो वो एक करेंगे. RAR में हमारा राइट शिफ्ट होगा ऐसा है, राइट. सो ऑल द बिट्स आर बीइंग शिफ्टेड. ये इधर जाएगा, ये इधर जाएगा, ये इधर जाएगा, ये इधर जाएगा, ऐसा. तो यहाँ पर हमने 81 लिया है. ये 81 कैसे हो जाएगा, 81H का क्या होगा, ये हम लोग वहां पे बता सकते हैं, राइट. So this is the rotate. Then we have circular left shift means RLC. Now without carry, not in the earlier. इसमें हम लोगों ने क्या किया, कैरी के थ्रू रोटेट करने के लिए बोला. अभी हम लोग विदाउट कैरी रोटेट कर रहे हैं, राइट. सो बिट D7 इज प्लेस्ड इन द पोजीशन ऑफ D0 एज वेल एज इन द कैरी. अब कैरी में वो D7 बिट जाएगा, पर कैरी का D0 बिट पर नहीं आएगा. हाँ, उसमें कैरी जाते जाएगा. तो हम लोग ये RLC वाला इंस्ट्रक्शन जो है वो यूज करते जाएंगे. कैरी फ्लैग इज बीइंग modified according to bit D7. So D7 bit में जो भी data है that is being moved to the carry. और RAL में क्या होता है, वो पूरा का पूरा कैरी से जाता है, यानी कैरी D0 पे आता है, D7 कैरी में जाता है, ऐसा करके वो रोटेट होता है, राइट, सर्कुलर शिफ्ट बोलते हैं हम लोग इसको. तो ऑल द फ्लैग्स आर बीइंग इफेक्टेड, और ये RLC एक्यूमुलेटर के लिए ही है ये इंस्ट्रक्शन, बाकी रजिस्टर्स के लिए नहीं है. RAR, RAL, RLC and RRC, right? These all instructions are concerned with the accumulator only, right? So these are all logical instructions. And last instruction is complement accumulator, CMA. Complement accumulator means the contents of the accumulator are being complemented. मतलब क्या हुआ, 1 का 0 हो गया, 0 का 1 हो गया, बस इतना ही. CMC कॉम्प्लीमेंट कैरी, मतलब कैरी अगर 1 है तो 0 हो जाए, 0 है तो 1. ये करने के लिए हम लोग ये इंस्ट्रक्शन यूज कर सकते हैं. आई होप ये इंस्ट्रक्शन हम बहुत रेयरली यूज करें. सो दिस इज देयर. देन वी हैव STC, दैट इज सेट कैरी. कैरी को सेट करने के लिए भी ये इंस्ट्रक्शन यूज करते हैं अगर वो रीसेट है. देन वी आर हैविंग, यस, so these are all instructions. I will just repeat it for you people again, and then we will try to close this. So today we have studied, say, some of the logical instructions, and hopefully we'll try to understand some branching instructions in the next class. So today we have studied around logical instructions. Let's recap those instructions again. So the first instructions, logical instructions, are add, or XOR, rotate, compare, and complement. Then the program status was that those are flags are being affected, and what is the meaning of reset and what is the meaning of set, that is written over there. Which bit is there for carry flag, status flag, sign 0, and that is shown. We have earlier studied this. Then ANDing operation, I have told you how AND operation is performed, and this is how the 2-bit ANDing is done. 2-bit ANDing is done in this truth table that we have studied in the first semester. And the same is to be done with the 8-bit. So this is one of the programs which I am expecting you to perform in your mobiles. Try that program at your home. Just you have to change one instruction instead of add and the data that is given over here. So we have used 90H and 35H, and it is stored in register A and register D. The result is to be stored in register C. Right, so this is the ANDing operation. This is how AND is performed. This is how XOR OR is performed. For your understanding, I have shown you that. So this was the ANDing operation, and we have started with some of the logical operations like rotate, compare, complement. All those instructions comes under the logical operations. So for some instructions, we have studied compare instructions. So compare R and compare M, which implies that we have to compare the contents of register or memory with the contents of the accumulator, right? So this is the instructions. Then compare, this are how the sum of the flags are being affected. Carry flag, set, reset, और ये बड़े greater और smaller check करने के लिए है. Then we are having a logical instruction, CPI, compare the immediate data. This is another instruction. Then we have what happens with CPI data, that is given over there. Then logical instructions like AND. So AND ANA are that AND register or memory with the accumulator. Then ANI immediate, that is AND immediate the data of the accumulator with the yes. I will just share my screen. Yeah, I hope it is visible to you. Am I visible? Anybody can tell that? Yes. Just 2 or 3 minutes are left, so we'll just complete all instruction. Thank you. And ANI operation. Then we have OR logical OR. Then we have ORI. Yes. Then we have XOR A. Then XRI. And then we are having some instructions like RAL, accumulator rotate, accumulator left through carry, like this. Then we are having RAR, that is rotate accumulator right with through carry. Then we have RLC. that is rotate only the accumulator without carry, right? So this is over there, and RLC, RRC, these are some instructions, and complement and carry flag, complement carry, set carry, and then okay. So these were all for today's class. So I hope if you are having some questions, you might ask those. I hope if there are some questions, you can ask those questions, and you can even put it on chat box. I will be putting this on in my YouTube channel. If you have not got anything, just try to ask questions, and we will be using those instructions in the coming classes. I hope there is no questions. Nobody is responding over here. So might be we can end this class today. So I hope you have got. Tomorrow we will continue with some branching group of instructions, right? So shall we end over here? Okay. Thank you very much for joining the class, and I hope the more attendance should come. Wait for a second. Thank you very much for joining the class, and I hope you have understood this logical group of instructions. And in the coming class, we'll try to solve some branching group of instructions. Thank you very much. Stay home, stay safe, take care. Bye. See you soon. Good day.